In this video, we're going to think about energy forms and how we can transform energy from one energy type to another. In this mind map here, you can see different forms of energy. Moving across the top, we have kinetic energy, that's movement energy, light energy, sound energy as objects vibrate, heat, or more correctly thermal energy, which is when energy is released by a hot object, electrical energy, which is what we're going to concentrate on today, and stored forms of energy, and these are all called potential energy. And you can have different types of potential energy. So chemical potential energy, you have that in your body when you've eaten some food, and then you can use that energy, you can transform it into heat energy or into movement energy. Sometimes things have elastic potential energy. So in the little diagram here, we've got a catapult, or it might be a spring that you can load up and then release, and then it might move or cause something to make a sound. And also gravitational potential energy, when an object or something like water has been raised up high, it then has the potential, the stored energy that can then be released as it falls from that high position. So these are different forms of energy, and let's have a look how we can move from one form to another. So in this little graphic here, we have a person who has lots of chemical potential energy. So you can see the little green E's in her body, and as she cycles, she moves the bicycle. So we have little blue energy symbols, and the wheel of her bicycle is driving this turbine here. And as that goes around, it spins a magnet inside this generator, and you can see that the kinetic energy, the grey E's, are being transformed into electrical energy, which is then powering this light bulb, and it's giving off light energy, the yellow E's. So when we look at this, we can write an energy chain. So we have chemical potential energy transformed into kinetic energy, which is transformed into electrical energy, which is transformed into light energy. But those of you who are observant will have noticed that sometimes this transformation is not perfect and you lose some energy. So did you notice this little red E here, which is thermal energy, being lost? So the friction that's happening as this girl is pedaling her bike is giving off heat energy, and that in this case is not a useful form of energy because we were wanting movement energy. And you'll notice, if you were very observant, that inside this light bulb there is also thermal energy being given off. So energy always has to be fully transferred from one thing to another, but it doesn't always go into the form that we want. And sometimes that can affect efficiency. So we'll be thinking about that over the next few lessons too. So let's have a look at the conservation of energy. This is when energy is transferred, and it's a sort of law of science that energy cannot be created or destroyed. So you always transfer all the energy. So in this case, we have 100 joules of electrical energy. Joules is the unit of electrical energy, and it's being transferred into light and heat. And some of that might be useful and some of it might not, but all of it is transferred. We can represent this in a different way, and this is called a Sankey diagram, with the arrows showing the proportional amount of energy going in different directions. So again, we've got our chemical energy, in this case is in a battery storing chemical energy, and it's being turned into light and heat or thermal energy. And you can see some of it is useful. There's 10 joules of useful energy and 90 joules of not very useful heat energy. But we're going to be thinking about how do we actually make electricity in the first place. It's electrical energy. So let's have a look at how we make electrical energy. A basic power station works in this way. The first thing we have to do is make a turbine turn around. So a turbine is a large fan, And that large fan, you can see it here in this diagram, drives a spinning magnet. So the spinning magnet is what turns the movement energy of the turbine into electrical energy. There are lots of different ways to cause the giant fan or the turbine to spin. We're going to consider ways of making it spin directly using water and wind, and we can also make it spin by generating steam. So let's start off with direct ways of making the turbine spin. And that first way is wind. So we have lots of wind farms in Australia. Here's a map surrounding, it's quite small to see, but surrounding the city of Goulburn. And Goulburn, there's lots of these wind farms that are either actually happening or they've been proposed, and they look like this picture. And the wind drives the blades around. That is the turbine, and then that makes a giant magnet spin and generates electricity. You can have wind farms offshore, but there are none in Australia. This is a map here of some proposed sites of offshore wind farms, and that's where we put the giant windmill actually into the sea. This is very popular in areas of Europe, for example. Now, another way to make the turbine spin directly is by using water flowing down a hill, and you can see the turbine here in this diagram under the ground in the Snowy Hydro system. So this is a picture here of the Snowy Hydro system in the Snowy Mountains. And as the water runs from a dam up high through tunnels and tubes into the turbine room, turbine spins, generates electricity by moving a magnet very fast, and then drains out the bottom. So this is direct use of water to make the turbine spin. You can also use the tide, so the sea as it moves in and out under the influence of the moon, and there's a system up in near Broome which is using tidal power. So let's go back to our basic power station working. So we have water and wind as ways of turning the turbine. Let's have a look at ways to generate steam. So we can generate steam in a few different ways. One way is to actually use hot water from the ground. This is geothermal energy, and this is a map here of Australia's areas where there's lots of hot rocks fairly close to the surface of Australia. And what you do is you pump water into the ground here, and you allow hot water to leave the ground as steam, and that turns a turbine, generates electricity, which can be fed into the grid. But sometimes we don't get hot water. We have to make the water hot, and there are lots of different ways that we can do that. We can burn coal to make the water hot. We can burn oil, natural gas, and not in Australia, but in other areas of the world, we can use a nuclear reactor to heat up water, turn it into steam, and drive the turbine. So that's what's happening here. So we can drive the turbine with steam, wind, or water. But there is another way. There is a way of using light energy and turning that into electrical energy. And that is what happens on solar farms. And here is a picture of a solar farm out at Broken Hill in New South Wales, out near the border with South Australia. And it's very sunny there. It's one of the sunniest places in Australia. So they've built a massive solar farm. You can get an idea of its scale by looking at some of the buildings down here. So small buildings, big solar farm, and these are popping up all over Australia because we have so much sun, and the light energy is directly converted into electrical energy.